and welcome to our new video where we discuss successive differentiation. Successive differentiation means everybody know differentiation means derivative of any function. Derivative of any function means we have to differentiate with respect to that function. If we have function y is equal to fx, if we differentiate this y with respect to x, then our first order derivative is called dy by dx. dy by dx is, we can write like this, dy by dx, or we can write like this, y1 also known as first order derivative. Then we differentiate given function one time with respect to x. Second order d2y by dx square, it is also known as y2, and we can write this with second order derivative, differentiate this given function two times. Similarly, third order for nth order derivative is known as yn, or d to the power ny upon dxn, and this is nth time differentiation with respect to x. So this is called successive differentiation. For example, if we have y is equal to 2x plus 5 to the power 5. Clear? And there we have to find out, question is find out the fourth derivative. So fourth derivative is called successive. y1, y2, y3, y4 means more than first order derivatives is called successive differentiation. So when we find out y1 means this is dy by dx, d by dx of this, d by dx of given function 2x plus 5 whole to the power 5. So how we differentiate? This term have power. So this term first we consider like any function of x. If we have x to the power 5, then differentiation of x to the power 5 is 5x to the power 4. Very good. Then this also 5 2x plus 5 to the power 4. Again, now this 2x, differentiation of this 2x is 2. Yes, so 2. This is y1. If we want second order derivative y2, again constant 5 here as it is. Now one time differentiation of this, so 4 comes 4 2x plus 5 to the power 3, and this one time again 2x, differentiation of 2x is 2. So 1 2 is already here, 2 to the power 2. This is second order differentiation. If we want third order y3, then y3 is again 5 4 3 2 x plus 5 to the power 2 and 2 to the power 3. This is third order, and last one is fourth order, 5 4 3 2 2x plus 5 to the power 1 2 to the power 4. One more we can find out the derivative, y5 is 5 4 3 2. Now this is no power, so this gives only 2 to the power 5. Clear? So again y6, y7 all are 0 because now it's determinant, it comes in constant form. So this is our derivative of given function. So means successive differentiation means you have to differentiate that function. How many times you have to differentiate, that is called the order of differentiation. Next is if we have non-terminate terms, like if y is equal to sine x, okay, then y1 is, if y is equal to sine ax plus b, we can determine in general form also, or sine x also. So y is equal to sine x, then dy by dx is cos x, again y2 is sine x, then y3 is cos x, like that. So if we talk about the general, General term means this we again write sine of 90 plus theta. So sine x plus pi by 2. Sine 90 plus theta is cos theta. This is again sine of x plus pi, 2 pi by 2. So y3 is x plus 3. So general term yn is equal to sine x plus n pi by 2. Nth derivative of sin x is sin x plus n pi by 2. Similarly, in the case of cos is also first y1 is cos is minus sin, then cos, then sin, then cos. So general term nth is cos of x plus n pi by 2. So these are called the successive differentiation. Regarding many function you can find out. Some we can use for if we have function where denominator have higher degree, then we use partial fraction, we break and then we differentiate. First one question is, if we have y is equal to x upon x minus 1, x minus 2, x minus 3. In this case, you can see our denominator is higher degree than the numerator. So you use the partial fraction just separately. First you use partial fraction, then apply the derivative differentiation. So x by x minus 1, x minus 2, x minus 3 is right as a upon x minus 1 plus b upon x minus 2 plus c upon x minus 3. Now with the help of partial fraction we have to find out the value of a, b, c. Means this part is equal to this, we factorize and then we can easily differentiate it. So how? Just x is equal to a of x minus 2, x minus 3 plus b. If you took the LCM, denominator cancel, just numerator will be there, x minus 1, x minus 3 plus c, x minus 1, x minus 2. Now first, if x is equal to 1, you put x is equal to 1, b is 0, c is 0, it gives value of a gives 1 by 2. If you put x is equal to 2, x is equal to 2, a gives 0, b gives value, c gives 0. So b here, in this case b gives minus of 2. If you put x is equal to 3, this 0, c gives a value, c is equal to 3 by 2. So when with the help of this partial fraction you have to find out a, b, c value of, then you substitute here. So 1 by 2 minus of 2, this is plus 3 by 2. Means this x upon x minus 1, x minus 2, x minus 3 is equal to this. Now we have to find out y1. If we want to find out y1, we use this term, means 1 by 2 d by dx of x minus 1 to the power minus 1 minus 2 d by dx of x minus 2 to the power minus of 1 plus 3 by 2 d by dx of x minus 3 to the power minus 1. Now you have to differentiate. This gives minus 1 x minus 1 to the power minus 2. This gives minus 1 x minus 1 to the power minus 2 and so on. So we have to differentiate easily each term. If we have 2x, for example, if we have 2x here, then you can multiply this derivative of this also, means first you take the differentiation minus 1, 2x minus 1 to the power minus of 2 and derivation of this 2x is 2. So 2 also, 1 2 is also comes here. If 2 is not there, no need to take any, only x derivative of x is 1, so just directly. So y1, again y2, y3 you can find out the, so any times you can derivative. Similarly, if we have some derivative like this, find nth term of sine x sine of 2x, means multiplication of two trigonometrical function. In this case we also cannot derivate directly. So if we have two trigonometrical function in multiplication form, we solve and we change this form into addition form. We have formula, so many formulas you can use and use change. You know, 2 of sine A sine B is equal to cos A plus B minus cos of A minus B gives 2 sine A sine B. 2 is not there, we have to divide, either multiply or divide. In this case we have to multiply, divide, and value of this 2 sine x sine 2x put here. So cos A cos B plus sine A sine B. This gives cos A cos B minus sine A sine B. A put 2x, B put x. This is A and this is B. So we can easily change. If we put A is equal to this, then y is changed into cos 3x, cos A plus B is 3x minus cos of x divided by 2. Now we can y1 if we want to find out. We can't able to differentiate, but now when we break into single function of trigonometrical, we can easily find the nth up to nth order derivative. Next, last one is the for successive differentiation. Very important role in this successive differentiation, or we can say very important role for find the nth order derivative is the Leibniz theorem. Basically, Leibniz theorem is what? With the help of this Leibniz theorem, we can find out the nth derivative of multiplication of two functions, but not this types of function where not one is deteriorate. We have to find out only those types of function where one will be terminate. If we have, for example, y is equal to e to the power ax into x5. This function we can easily use, find the nth order derivative with the help of Leibniz theorem, but we have e to the power ax cos of bx. We can't find the value of this nth order with the help of Leibniz. Leibniz have definitely one function have to terminate or one function has to vanish and other can be repeat or nth derivative. So now I will explain you what is the Leibniz theorem. So Leibniz theorem statement, or I can't give the proof, I just write the statement. This is very helpful to find the nth order derivative, very useful to find solving the differential equation. If y is function of u and v both function of x here, then what our Leibniz say? Leibniz say y is equal to, I will give you the proper format of Leibniz theorem. Then y is equal to nc1. We don't write nc1. I will give you y is equal to nc0 u and v plus nc1 u n minus 1 v1 plus nc2 u n minus 2 v2 up to plus ncn u v n. This is Leibniz. So what is the value of nc0? nc0 is 1 and ncn is also 1. nc1 is n. So I will rewrite in simple form. If you want to in simple form, then our Leibniz is u, this is 1. So u n v plus nc1 is n u n minus 1 v1 plus NC2. Here is NC2 term. So NC2 is n minus 1 by 2 u n minus 2 v2 and plus so on. Third term is n minus 1 n minus 2 upon this is factorial 2. That is factorial 3. Factorial 3 means 1 into 2 into 3 means that is denominator is 6. So last term is u v n. And because I already know NC0 and NCn is equal to 1. NC1 is equal to n is equal to NCn minus 1. So these are the combination you can find out with this, or otherwise you can use this format of Leibniz theorem directly. So this is our Leibniz theorem. Now I will give you one example that how you have to apply this Leibniz for finding the nth order derivative. So we discuss one problem on it. We have discussed. Okay, question is y is equal to x cube log of x. I already told you here we decide there are two functions u and v, both function of x, but which is u and which is v, then this is our v and this is u. V always terminate, vanished, u is cannot be. So we have to decide v is the function which is finished after some derivative. So here our v is this, u is this. Now separately we have to find out if u is equal to log x, then u1 is equal to 1 by x, then u2 1 by x means x to the power minus 1. u1 means d by dx of u, second order derivative, minus x to the power minus of 2. u3 is again minus minus plus 2x to the power minus of 3 and so on. So we have to find out this in generalized form. So generalized form is what? If we want to write un, so un is minus, there is 1 plus 1 minus 1 plus 1 minus 1. So minus 1 to the power n minus 1. If we put, see, if n is equal to 0, n is equal to 1, 1 minus 1 is 0. If n is equal to 2, it negative sign. So minus 1 to the power n minus 1, x to the power at 1 is 1, 2 is 2, 3 is 3, x to the power minus of n at 1, 1, 2 is also 1, 3 is 2. So multiply with the what? Multiply with n minus 1 term. So this is the general form of un. Similarly, we have to find out v is x cube, then v1 is 3x square, first order derivative, v2 is 3 into 2, 6x, v3 is 6, and from v4 it goes 0. So we have to write up to 4 terms. We have to write un into v here, un minus 1 just before one term, and v1 this term, this with un minus 2 and v2, and next term is un minus 3, v3. Only this 3 terms gives the nth term of given function. So we have to decide only which is u and which is v, and we can easily find out. One more example, if you have y is equal to x square cos x, same, this is v, this is u. If u is equal to cos x, what is u1? u1 is minus sin x cos x. So that I directly cos un is cos x plus n pi by 2. I previously also. So and v is x square. So v1 is 2x, v2 is 2, and all other is 0. So now you have to find out yn with the help of Leibniz. So Leibniz un is cos x plus n pi by 2 into un into v is x square plus un minus 1. So cos x plus n minus 1 pi by 2 v1, it means 2x plus n minus 1 by 2 un minus 1 un minus 2. So n minus 2 gives cos x plus n minus 2 upon into pi by 2 and v2 is 2. Finish, because more term v3 v4 all are 0. When we multiply with other term, it also gives 0. So our nth derivative of this given function is this. You just simplify it, you will get the nth derivative of x square cos x. Similarly, we can use this for solving the differential equation or many equations. I will solve one equation. I will give you one equation for you, how we can use this Leibniz theorem to solve the equations. Now if we have y is equal to x square minus 1 to the power n, then prove that x square minus 1 y n plus 2 plus 2x y n plus 1 minus n plus 1 y n is equal to 0. So in this case, first you have to find out yn for this. y1 is what? n x square minus 1 to the power n minus 1, and this derivative of this x square is 2x. So this is y1. Okay, so we again write y1 is 2x and x square minus 1 to the power n minus 1. Clear? So this is our y1. Next, again we have to find out y2, or we again write out, if we can write 2x and y is this. So there is x to the power n, there is x to the power n, means 1 and x square minus 1 is x. So we write like this. Can we? So y1 is equal to this one. Again simplify it. So x square minus 1 y1 is equal to 2nxy. Clear? Now one more time differentiate it, we will get y2, because when we get the y2, then nth time derivative is for y2 is yn plus 2, nth time derivative of y1 is yn plus 1. So we apply on that equation, we apply the Leibniz. So next step, with this one more time differentiated with respect to x. So when we differentiate this, so x square minus 1 gives 2xy1 plus x square minus 1 as it is, derivation of y1 is y2, right hand side gives 2 and x gives 1y plus 2 and x y1. Understood? This x and y, so multiplication of two function, when we derivative with respect to x is 1, y as it is, when we derivative with respect to y, x as it is, derivative of y is dy by dx, that is y1. Clear? Now you again simplify the equation. X square minus 1 y2. y2 is only this term. Then y1 this and this. So combine these two terms. 2x is common. 1 plus n. 1 plus n. 1 plus n y1. Sorry, 1 minus, this comes this side. Then 1 minus n. Next is minus of 2ny is gives 0. So our equation is this one, x square minus 1 y2 plus 2x 1 minus n y1 minus 2ny equal to 0. Now you have to apply the Leibniz in each term for taking the nth order derivative. When you apply, there are 3 terms. Now in this case, this is v, this is u. In this case, this is u, sorry, this is v, this is u. Here just only one function, nth derivative of 2ny is 2n yn. Clear? So now I will apply Leibniz. So when we applying the Leibniz, first applying the Leibniz, nth derivative. So what is our un? Un means yn plus 2. Nth derivative of y2 is n plus 2. V is x square minus 1 plus n. Un minus 1 means y of n plus 1. The derivative of this is 2x plus n minus 1 by 2. One more derivative reducing means yn, and derivative of this is just 2. No more term, because after that all is 0. So this we apply in first term, plus we take constant outside. 2 1 minus n is outside. Next xn, our v is x. This, so y, first term vn, yn plus 1 x plus n yn, derivative of x is 1 only. Finish. Minus 2n y of n equal to 0. Clear? So this gives second term and this gives last term. Just now you simplify it, you will get the required solution. What is given? X square minus 1 y n plus 2 plus 2 xy y n plus 1 minus n plus 1 y n is equal to 0. So when you simplify this equation, you will get this. So these types of question also we can solve with the help of Leibniz theorem. So that's all for successive differentiation. I think this video is helpful to understanding how to solve higher order derivative for first order, second order, fourth order. Means you just